Let's begin with quadratic probing. Okay, let's see how it calculates a new slot. Okay, so it is a small difference from the linear probing. The code is exactly the same, but the difference is in the hash function. So how the hash function is calculated is, let's say the size this time is 11. Okay, so 31 mod 11 will give me a value of 9. So at an index 9, 31 will be added. Correct. Now 19 mod 11 will give me 8. So it is empty. So 19 will be added. Now 2 mod 11 will give me 2. So similarly here 2 will be added. 13 mod 11 will give me a 2. Now here there is a collision. So what it does is, next what it will do, whatever first index was there, okay, using the first index that we got. So since it is the first time collision, it will give me 2 to the power of 2 plus 1 square. So it is nothing but 3. So at 3, 13 will be added. Okay, now 25 mod 11 will give me a value of 3, but 3 is already full. So 3 plus 1 square, because this is first collision for 25, so it will simply become 4. So at 4, 25 will be added. Okay, now 24 mod 11 will give me a value of 2. Now 2 is already full, so 2 plus 1 square will give me 3. Now 3 is also already full. Now 2 plus 2 square, the first index that we got, in that only we need to add the squares, because this is second time collision. So 2 plus 2 square, that this is nothing but the number of time collision has occurred. This is the first time, this is the second time. 2 square is 4, 4 plus 2 is 6. So at 6, 24 will be added. Okay, now it is 21 mod 11. 21 mod 11 is nothing but 10, so it is nothing but 21 here. And then we come to 9. So now 9 mod 11 is 9. Okay, now at 9 there is already 31, so here it will be 9 plus 1 square. Now 1 square, 9 plus 1 square is nothing but 10, but 10 is already full. Okay, so it will be nothing but 9 plus 2 square. It will obviously wrap around as same. So 9 plus 2 square mod 11. So everything is mod 11. Okay, 9 plus 2 square is nothing but 13. So 13 mod 11 will give me a value of 2, but 2 is already full. So again we need to do this. So this is the third time collision. So 3 square, third time collision square. So it will become 9 plus 6, that is 15. Now 15 mod 11. 15 mod 11 is nothing but 3 square is 6. 6 and 9 becomes 15. And 15 mod 11 will give me the value of 4, but 4 is already full. This I have made a mistake. It is 3 square. 3 square is nothing but 9. So 9 plus 9 will become 18. 18 mod 11 will become 7, and here 7 at 9 will be added. So this is how quadratic probing works. So what is the hash function in this is, whatever hash function we are using mod of max, the max capacity of the table. So hash of key will give me an index. Now using this index we will do quadratic probing. So hash dash of key I will represent the number of times that collision has occurred, equals to whatever the key index was there, that is index, original index, plus I square mod our hash function, that is nothing but the max size. Fine. So this is our new hash function. Okay, now just substitute the values. So it is 1, so it will be 1 square, index plus 1 square, that we are already done above. Then when I value is 2, that is 2 times collision, so index plus 2 square. If it is again, then index plus 3 square. Okay, and we will stop when when this particular hash value returns me the index again. So we have already done that particular thing. Now here the clustering does not happen, but the problem in this one is, if we have 2 and something else comes, let's say 13. So 13 comes, so it will begin with 2, and 2 also begin with 2. Now if something comes, let's say 24, so you see 24 has begun with 2 also, then it goes to 3. 13 was also going to 3, then it goes to 6. Okay, so the same prop sequence will be followed in this also. Same prop sequence will be followed. Okay, so if it is 24, so 24 will go to 2, then it will go to 3, then it will be going to 6. The same prop sequence it will be followed for, let's say 35. For 35 also the same prop sequence. First it will go to 2, okay, then it will go to 3, then it will go to 6, and then it will calculate the another value. Fine. So this is the problem in this one also. And the second problem it has, it is not guaranteed that all the hash slots will be checked before saying that the hash table is full. It is not guaranteed in quadratic probing. In linear probing, it is guaranteed that each and every hash slot will be checked before saying that yes, the hash table is full. But it is not guaranteed in the quadratic probing, and that is the reason it is not practically used. Fine. So we will see the code for this, and it is a very small code. Now there is no much change in the code. Only we have to change this hash function, and nothing else we have to change in the particular code. Okay. Now let's see the code behind this. So let's see the implementation here of quadratic probing. It has the exact same code as the linear probing, only the class names have been changed according to the quadratic probing and nothing else. Okay. One more change is obviously in the hash function. So you have p equals to 1, and this is our hash function. So index plus 1 square, then p plus index plus 2 square, then index plus 3 square. So the number of collisions square. That's it. This is only the change and nothing else. Similarly in the hash function, this is the change. Fine. So exact same code, only the hash function is changing and the class names are changing and nothing else. So just run it, and for the test case, let's see its values. So there are 11 capacity, and we are giving the inputs, and these are all the values. So 25 is present in the hash table. Let's see. Yes, 25 is present in the hash table. So it is saying 25 is present right here in the search element function. Then the size of the hash table, and when we clear it, the size becomes 0. So this is the implementation of quadratic probing. Nothing but change, only a few changes from the linear probing. Okay, thank you.